of dart cars, which are cars, like toy cars that have a pullback motor. In my case though, I got this in the early 90s and I haven't used it in at least a decade, so the motor didn't really work that well, so I push it with my hand. I know it's kind of defeats the purpose, but what you gonna do? As you saw in the video, I conducted a run with a car going through a straight track and then a loop track. And ideally, the loop should yield the same output distance, or the R2 variable, and the straight track, because the energy that it loses going up the loop is gained again going back down. No, that's an ideal situation. In reality, there's going to be friction that would cause the car's overall speed to decrease, and probably the distance decrease as well. And I tried using Logger Pro to graph it, but as you can see, it's not successful because obviously, it's showing the position going down and then going up again. It's because I moved the camera, I think, so it was just kind of hard to get the exact distance in there. So I probably could have did it if I used multiple files, but it was too tricky for me, and I was already spending too much time on it anyway. Anyways, so I just did it the old-fashioned way, just by using the algebraic methods and formulas that we used on our spiral kinematics assignment last weekend. And I also forgot to mention, so since I didn't have the motor, I pushed it with my hand. I try to use the same force each time, but of course it's kind of impossible to do. With the motor, I would have been able to rev it up the exact same amount. Alright, so here are the mathematics that I did. Here are just some quick measurements that I used to take. I could have measured everything, but Pythagorean theorem, because the car didn't go exactly in a straight path, so I used Pythagorean theorem, and like I said, I could have measured it, but what's the fun in that? And so here's my computations for the straight track. Same exact process as what we used in the kinematics assignment. R1 starts at 0 centimeters. That might be actually, that's right. Velocity, this is what the variables were, velocity and acceleration, and here's all the math I did to find them below. Time, I knew that from the video. R2, I measured that. Velocity, second one stopped, so it's gonna be 0, of course. I knew that from the video as well. Ending time, start time, end. Acceleration and velocity is what I need to find out. And it's losing energy, so of course the acceleration is going to be negative. Alright, and then here's what I have for a loop. Same process. Coincidentally, the initial velocity was just about 1.5 centimeters a second off, which is real strange. Probably means I put more force into this run because so it could overcome the friction that it may have possibly gained through the loop track. The accelerations, yeah, they should be the same, because they're not though. About 15 units difference, because of the initial velocity. Perhaps the different path mean the car could have collected some dust during this run. Another vector, left right wise, could have caused it to go kind of straight a little bit. Maybe that interfered with it. Maybe just some possible rooms of error. And here's try to make an equation of it. So here's a formula for distance based on acceleration. It's initial velocity times time plus half of acceleration times time squared plus the initial location. So plug that all in. Comes out to be 220.1 centimeters a second times time plus 0.5 times negative 66.70 centimeters a second squared times time squared plus 0, because initial 0 centimeters. Here's what it would look like if you were to put it into your graphing calculator. the same thing for this is the loop one, and this is the track one right here. So this is that's what it will look like. You wanted to see the curve, maybe find out what the velocity is at our position at individual times. Wrong one. Alright, here we go. Alright, so here's the second one that I have, the loop track. I mean, not the loop track, the straight track, I'm sorry. There's the graph. If you wanted to find out where it stopped, you calculate the maximum. Go to the left bit. Very close to what we got for the final distance is what I measured. It was only about a couple of decimals off, probably due to rounding errors and whatnot, not carrying over enough decimals in my math. Alright, and that's pretty much it. Oh yeah, and the graph, it should be straight right here because you're stopped. I could have also used a regression formula and gathered various points, distances at respective times, but it was just too hard to discern from the video which distance was what. But if I was to do that and plug it into the calculator, I'll program, where is it? I should know where this is, but stat. Calculate, and then you calculate a quadratic regression based on your tabular formulas, and then do essentially the same thing as what Logger Pro does. Alright, I think that's it. Thanks for watching, and sorry for going a little bit over.